Hello people of YouTube. Okay, so today I'm going to be trying to show you, attempt to explain to you how to convert from denary to binary and vice versa if we get down to there. So, firstly, you want to make this table that I've got here and you want to fill it out with the following. Now, let me just explain to you what these numbers are and why they're written from right to left. So firstly, they're written from right to left because you work from left to right. So basically you're going to be, let's say you got a denary number, you're going to be going, does it go into this? No. Does it go into that? No. And then you might find one that it does go into. Whereas it make no sense if you went from this direction because you'd obviously not know what's coming up. And what are these numbers? Well, these numbers are here for a reason. So they're doubles of each other. So 1 double, 2 doubled, 4 doubled 8, and carry on. So etc. Anyway, so this is the header that you use for converting to binary. I'm gonna put an example up here now. So what I'm just going to simply do is I'm going to put let's start with something easy. I'm going to put a 10 here. So I want to know what 10 is in binary. So what we have to start off by doing is thinking, well, does 128 go into 10? And hopefully that should come quite easily to you that it doesn't. So that is 0. Does 64 go into 10? No, so it's a 0. 32 obviously does not, and so with 16. But now we've got 8. 8 goes into 10 once, and it's got 2 remainders. So we put a 1, and obviously in binary we only use 1s and 0s to use the minimum amount of storage as possible. Because if you're using 2-digit things, the storage becomes more full. Now, denary, I didn't explain, it's just our number system. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. So, anyway, 8 goes into 10 once. So that's why we put a 1 down. Now, obviously, it doesn't just go into 10 once and then just the rest disappears. We still have to carry through a remainder over to the next thing. So, although we have cancelled this 10 down a bit, we still have a remainder 2 because 8 leaves 10 at 2 when you take 8 from 10. Anyway, so we're left with 2. Does 4 go into 2? No, it doesn't. So another 0. So far we've got 0, 0, 0, 0, 1, 0. But 2 does go into 2 once, leaving nothing behind. So our end result is 0, 0, 0, 0, 1, 0, 1, 0. Now this is an 8-bit digit, so this is called 8-bit. And you can do 4-bit. So 4 numbers as small as this, you can just draw a line here and just work with these 4 numbers. So say we're doing from 1 to 10. 1 would just be a 0, 0, 0, 1, because obviously none of these go into 1 and then 1 goes into 1 once, leaving nothing behind, and etc. So 0, 0, 0. Oh, sorry, no, my mistake. So I've messed up there. Obviously, here we've got a 1 because 2 goes into 2 once, and then we were left with another 0 because there's no remainder. So what this is basically this is for the low numbers. So from numbers up to 15, and then when we start to get to 17, numbers up to 16, sorry. And when we start to use numbers up to 15. And then when we start to use 16, we go to this one, but we'll obviously just use the entire header. So, you may have noticed that there's a 0 at the end here, and there's a 0 at the end here, but there's a 1 at the end here, and this is for the number 1, and this one's 2. So, the reason this is because this is an odd number. And all of the odd numbers in binary have a 1 at the end. So that's quite helpful really to see if you've gone wrong, because for mistakes such as one number mistakes, maybe you've gone wrong by one number, but you can kind of confirm that you've gone semi-well if you've got a 1 at the end and you're trying to translate an odd number to binary, because that one shows you that you're ending up with an odd number in binary, so you must have done something right. Anyway, that's simple stuff for converting from Denary, our number system, to binary. Let's remove all these numbers. Hopefully you've forgotten them. Not because I want you to lose, but because I want you to think about this. Now, we have 4 4-bit numbers here, and what we're going to try and do is translate these back into Denary, because what's the point if you've got a page of binary code and you can't even understand what you've written once you've done it. So you need to be able to understand what you've done. So we've got 1A and 1-2 here, and it will shock you, but this is probably the most simple thing about this. It's literally 8 plus 2, and obviously I remember now we had 10. Sorry about my awful writing, this is my first time writing on paint. 8 and 2, 10. That's it, that is all you have to do, and that is this right here. And that's all you have to do with things like converting binary to Denary, because you are basically just reversing the process. So with this one, you've got 0, 8, 0, 4, 0, 2s, and you've got 1, 1, obviously indicating that we are using a 1. Really simple, 1, 2, nothing else. So, you guessed it, we got a 2. That's pretty much all you need to know for now. I will bring out some more videos like why you need to use binary and why you need to use hexadecimal. Hexadecimal is another coding format. I will quickly show you what the header is for that. In fact, so I'm going to leave the header for a future video, but I will just show you quickly what the number system is. So it's really simple. It's just 1, 2, 3, 4, 5, 6. Oh my god, I can't. I'm sorry, I'm not settling with that 6. Let's just do that. Sorry about that. 6, 7, 8, 9, and then no 10. We don't count to 10 in hexadecimal. We start with the capital A, capital B, capital C, capital D. Oh my god, I can't even write. And E. And if I can be so... sorry about that, guys. F. Okay, so that is our number system for hexadecimal. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. We stop at F because that's all we need, because you'll see in a future video when we use hexadecimal header, which I'll just quickly give you a sneak peek, is 1 and 16, and then it's 16, 10, 16. But you'll see that in a future video. Alright everybody, so I hope that helped you in some way, shape or form. But I also hope that you kind of enjoyed the video. But if not, I'm sorry. But if you did, if you like and subscribe, and if you hit the bell button, you will be notified when I upload any more tutorials like this to help you out. You may have watched this just to learn early about hexadecimal or binary, or you might not have understood. So I hope this helped, as I said. And yeah, goodbye.